Sholto Douglas was a key part of Anthropic's Claude 4 models. It was really fun to sit down with him on the day these models got released. We talked about a bunch of things, including how developers and builders should think about this next generation of Anthropic models. We talked about what the trend line mean for where these models will be in 6-12 months and 2-3 years from now. We hit on what's required for reliable agents and when these models will get better in domains like medicine and law, kind of mirror the advances they've already made in coding. And then we hit on his views on alignment research, where we are today, what's working, what still needs to be done, and his reaction to the AI 2027 work. This was just a fascinating conversation with a brilliant mind in LLM research. I think people will really enjoy it. Without further ado, here's Sholto. Well, thanks so much for coming on the podcast.
No, it's a joy. It's a really cool little room.
Yeah, no, I appreciate you getting in this this little cave with us.
Yeah.
It's always fun. By the time this podcast comes out, well, the world will have Claude 4. I'm sure people will play around with it, but I'm curious. You're one of the first people to get to play around with these models. What gets you most excited about them?
So they're another step up in software engineering, that's for sure. And Opus is like really an incredible software engineering model. Like more and more, I have these moments where I go and ask it to do something incredibly ill-specified in like our large monorepo, and it's able to go and do it in quite autonomous and independent way. They're going and discovering the information and figuring this out, running up the tests, and that blows me away every time.
Like every time we get a new set of models, we have to like re-characterize a mental model of like what works, what doesn't.
Right.
Like how has your model now changed of, when you're coding, like what you use these models for and don't, with the sleep?
So I think the biggest one is time horizon expands a little. So I think you can characterize model capability improvements along two axes. One of those is like the absolute intellectual complexity of the task, and the other one is the amount of context or the amount of like successive actions that they're able to like meaningfully reason over and agree. And these models feel substantially better along the second axis. Like they're really able to take multiple actions and like figure out what information they need to pull in from their environments and then act on those.
Yeah.
So giving it like. It's the time horizon. Also, the support that we like Claude Code and this kind of stuff. The fact that it now has access to all of the tools to be able to do this in a useful way, and you aren't sitting there like copy pasting from a chat box is like a pretty meaningful improvement in that regard too. There is a wide variety of tasks where I'm looking at an hour plus or like many hours of work where I would have done, and it's just there churning away in front of me doing these, like in terms of human equivalent time.
People are going to get these models when this podcast comes out for the first time. What's your like advice on the first thing they should try?
First thing they should try. I think honestly, try and plug them into your work. That's the biggest one. Is like sit down and ask it to do the same thing, the thing that you were about to do first off in your code base that day. And watch as it figures out what information it needs to pull in and figures out what to do. And I think you'll be pretty impressed.
Yeah. I mean, now that you have these new capabilities, obviously you have tons of people that build on top of these models. Like, what are you hoping is like newly enabled for builders that take these models and build applications?
So I think there's this concept of like a product exponential in some respects, where you have to be constantly building just ahead of the model's capabilities. Yeah. And I like to think about this in terms of like say like Cursor and Windsurf and Devon and these products. If you look at Cursor, they had a vision for what coding would be that was substantially ahead of where the sort of model capabilities were for a while. Cursor didn't hit PMF until the underlying models like Claude 3.5 Sonnet took off such that the assistance that they wanted to give people was like able to like be realized. And then Windsurf went, I would say, like substantially more agentic, and that enabled them to get a reasonable slice of market share by really pressing harder on that product exponential. Yeah. What we're starting to see now with Claude Code, but also with the new Claude Github integration and with OpenAI's Codex, and also Google's coding agents. So everyone's releasing coding agents. Is
Jules,
people,
right?
Jules, right? Is people building for another level of sort of autonomy and asynchronicity? And so. Right now, the models are taking these stumbling steps towards being able to do tasks independently of you, the kind of tasks that would have taken you several hours before. What that looks like next, I think, is there's this interesting transferal of you are in the loop every second to you are in the loop like every minute to you're in the loop every hour that we've seen over the course of last year. And I wonder if it doesn't look like you're managing like a fleet of like of models in future. And so I think that kind of interface would be very interesting to explore. Like just how much parallelism can you give someone when it's not a single model they're managing, but multiple models doing multiple things and interacting with each other. I think that would be pretty exciting.
Yeah. Have you seen it? Like what might that look like?
What might that look like? Oh God. I mean, I know a lot of people actually at Anthropic who are like have multiple Claude code like instances up in different dev boxes, which is pretty cool. But I think no one's really cracked that form factor yet. And I think that's like an interesting form factor to explore of what is the almost management bandwidth of an individual. I think this is also an interesting question to explore from like the future of like how does economics even work, or like what are the sort of like return on productivity of these models? Because if you think like we initially will need humans to verify the outputs of these models.
Yep.
And so the economic impact of the models will be like at like some initial point bottlenecked by human management bandwidth until you get to the point where you can like delegate the trust in a model to itself manage teams of models. And so that like continual step up in hierarchy of like abstraction layers will be, I think, one of the more important like trend lines to
so basically you have based on the frequency with which you need to check these models, you become a gating factor. And like you have infinite number of models running, and you're if you have to check them every 15 minutes versus every hour versus every 5 hours, you can do a lot more. Yeah,
exactly. I think Jensen mentioned this with respect to like how he felt about the future of AGI in progress and this kind of thing. He said, well, actually, I am surrounded by 100,000 incredibly intelligent AGIs. And he's like, so like this gives me huge leverage over the world and like that's sort of the impact. And he's describing how like he himself is like this gating factor in like managing the company of NVIDIA. I think a lot of work ends up looking close to that direction.
Yeah, who knows? I mean, maybe this this whole field of org design ends up being actually the most important. What is the org structure?
Exactly.
And
how do you like innate like trust and yeah, exactly. Org structure becomes complicated.
Yeah, I know what you were saying before the episode that you did spend a year at McKinsey before, and I feel like, hey, maybe this is a good use case for the consulting firms, who have been doing years of this.
Maybe, yeah.
Seems like a good new product line for them. Actually, I was really struck by this, what you just said about how basically, for the app companies, it's about being, a stage ahead of like where the models are going, and Cursor did this. The models change so quickly that it's like almost if you think about like, what Cursor did versus like the kind of agentic coding companies like Cognition to like maybe someone thinking through now like what is the dashboard that you use to manage like your 100-person team.
Exactly.
Like, what is like the right level of ahead in your mind to go? Because it feels like you may feel like, oh God, I'm really out on my skis today, and then in 3 months you'll be like, actually, I'm way behind where the model capabilities were.
And you have to constantly reinvent the product to be like suitable for the sort of frontier of model capabilities. A few months ahead, maybe. I think is a sensible place. So you still like maintain a lot of contact with like direct users and this kind of stuff, and the product works to some degree, but then it allows you to take advantage of the frontier capabilities.
I feel like that's the risk because you have while you're kind of waiting for the models to get somewhere, someone else is taking up your customer, the developer love and your customer base, and they can probably integrate in some of this stuff as it
right, exactly, and you saw that also with Cursor and Windsurf and this kind of thing, right?
There's a lot of things in these models that you guys made progress on, like memory, instruction following, tool use. So I guess again, kind of recontextualizing for folks, like where are we in these 3 areas?
Yes.
What works, what doesn't?
Yes. Okay. So a good way to think about what's happened with these models over the last year is because RL finally really worked on top of language models, there's, I think, no direct ceiling to the intellectual complexity that we've been able to like teach these, like the intellectual complexity of tasks with which we've been able to teach these models. So you see them doing incredibly complex math problems, incredibly complex like coding problems, but those things are like in scoped domains with like we're relatively limited context. The problem's there in front of the model. Things like memory and tool use, these are attempts to expand the set of like the sort of context with which the model is able to like the context within which the model is able to act and the affordances it has. So this is things like MCP allow it to suddenly the world opens up to it and it's able to interact with the outside world. Memory allows it to run with much longer context, much greater degrees of personalization than just a raw model with its own context window. And so I think those efforts represent attempts to like crack agency by giving the model all these unhobblings in one respect. And I think the Pokemon eval is I love
that eval.
It's great.
As an avid Game Boy player back in the day, I feel like it's a great one. I hope you're going to release that alongside this model.
Yeah, the new model has been playing Pokemon, so you'll see that. I think it's a great eval because it hasn't been trained for.
Yeah.
And so it demonstrates this like generalizability of intelligence to like, I mean, a task which is not completely out of distribution, but one which is like meaningfully different from anything that's done before. And another example,
I had to buy a strategy guide to beat that game. I remember,
Right.
like, there's a lot of ladders and like places to go around.
Exactly. Another example of this that I really like is there's been a recent interpretability agent that Anthropic's been working on. Basically, what this does is it does that job of finding circuits in language models. And this is really, really cool because one, we haven't trained for it to do this. We've trained for it to, it's a coding agent, right? But it's able to mix that with its knowledge of theory of mind and this kind of thing to sit there and itself talk to the model that it's trying to understand, try and reason through what kind of, it has access to tools which are like looking at visualizing, neurons and circuits and this kind of thing. And it is actually able to win this interesting like alignment safety eval, which is called the auditing game, where you twist the model in some way and it has to figure out what is wrong with the model. And it is able to do that. It's able to talk to the model, generate its own hypotheses about what might be wrong with the model, and look at all these tools. I think it's just such a brilliant demonstration of the like generalizable competence of these models with access to tools and memory and this kind of
Totally. I feel like builders been waiting for, agents and, the ability to kind of use this stuff reliably. I think you've talked before on podcasts. So like the varied agents is reliability, right?
Yes.
How much progress have we made there? Like, for the builders that are listeners here?
Hey guys, this is Rashad. I'm the producer of Unsupervised Learning, and I just wanted to take a quick break from the conversation to remind you to subscribe to this YouTube channel if you haven't already. Subscriptions help us grow and help us continue to bring on the best guests like Sholto. So thank you so much for listening, and now back to the episode. Please subscribe to our channel.
The varied agents is reliability, right?
Yes.
How much progress have we made there? Like, for the builders that are listeners here?
I really like the media eval for that. I really do think that measuring success rate over time horizon is the right way to think about this, extension of agent capabilities. And I think we're making a hell of a lot of progress. We're not 100% there on reliability. These models don't succeed all the time. There's still a meaningful gap between the performance of the model when you ask it to do something once versus when you ask it to try 256 times. There's many evals where you can like completely solve them, with many attempts, but on the first time it's not guaranteed.
Yeah.
But that being said, I think every trend line I'm seeing says that we are on track to get like expert superhuman reliability at most things that we train on.
Yeah. What would change your mind on that?
I think if we were to basically like fall off trend line. So if, let's say, by the middle of next year, you started to see some kind of a block on the time horizon with which these models are capable of acting. And I think you should look at that, like coding is always the leading indicator in AI. So I think you would see that drop off in coding first.
Yeah.
But that would be perhaps reflective of inherent limitations in the algorithm, which I really strongly believe there aren't. There are other limitations where the task distribution might be harder than you think, because there's less data available for something, and it turns out to be actually quite a laborious process. And so maybe if you think about like computer using agents, then this would be an example where it's that kind of data doesn't natively exist. But at the same time, also we're seeing just such incredible progress there that it feels to me like relatively. I don't think that that's the world we're in at all.
Yeah. Well, when do you think I'll have like one of these just general purpose agents that can, fill out all my forms for me and, navigate the internet for me?
Yeah. One thing I joke about is like personal admin escape velocity. Like how can I put off doing a task until...
As a procrastinator, that would be wonderful.
Right. Exactly. It depends. I still think there's a meaningful... this depends a bit on the whether or not a company focuses on putting at least something like giving the model some practice reps. Like if you took a human off the street and you were like, you're a general intelligence, but like I'm going to ask you to do my accounting and you're not going to make any mistakes.
Right.
Probably the person you pull off the street makes some mistakes, right? But if they've like done something similar to it, or they're a great mathematician or something like this, then probably they will make many, or they're a lawyer or whatever. Like if there's something for them to generalize from and map to, then they'll be able to do it with a much higher degree of likelihood. So strong depends on what task. By the end of next year, I think we should see it should be very obvious that this is near guaranteed. Even by the end of this year, that should be like pretty clear. But by the end of next year, you'll have these things going around, doing a lot of things for you in your browsers. It'd be,
Sounds great to me. Your models are really good at coding. Like, what makes them so uniquely good at coding? Is it like a prioritization internally, or like what? I think like people associate Anthropic as like, oh, they're the coding model company these days.
Yeah.
Like, what is behind that?
I mean, Anthropic does care a lot about prioritizing the things we think are important, and we believe coding is extremely important because coding is that first step in which you will see AI research itself being accelerated. And so we care a lot about coding. We care a lot about measuring progress on coding. We think it's the most sort of important leading indicator of model capabilities. I think it's a focus.
Is coding accelerate? Or are these agents accelerating AI research today?
Accelerates me a lot. Yes, basically yes. They accelerate the engineering a lot. I think it's interesting to ask even people who are utterly brilliant engineers, like how much this is accelerating. A lot of my friends who I would regard as like the strongest people I've ever worked with, they say it's like 1.5x even on domains they know well. Yeah. And on domains which they don't know well, it's like 5x. So if it's new programming languages or something you haven't done for a while, it's an incredible accelerant. Now, it's one like very important factor to consider on like how much will AI accelerate AI progress is how much you believe that we are compute bounded or not compute bounded.
Yeah.
And so whether you think that if you say deploy AI agents who can do the research for you, will that mean that you get sort of like gains proportional to the amount of like researchers that you're now deploying?
At this stage, I imagine it's like most of these things can do the annoying parts of your job, so you can think about the brilliant pieces of research to like go test. I mean, do you find how do you think about the timeline for where these agents themselves are proposing like interesting research directions?
I mean, a lot of the work is engineering work. Yeah. I'd say the majority of the work is engineering work at this point in time. When they're proposing novel ideas, I'm not sure, to be honest. Within the next 2 years, I think people are already starting to see interesting scientific proposals and this kind of stuff. I think also if you allow an important thing to consider in the current sort of space of algorithms, these models, is they can become truly expert at something provided they've had a feedback loop for that thing. Yeah. So it needs to have been allowed to practice a little bit in the same way that humans need to.
Well, it also needs to be relatively easily verifiable, right? Are we going to get these models that are unbelievable coders and haven't made the slightest progress in some of these more nebulous fields?
Domains. Yeah. One point is that ML research is actually incredibly verifiable. Did the loss go down? Right. So if you can get to the point where you can make meaningful your proposals for ML research, you have the best RL task in the world. Even more so, I'd say than general software engineering in some respects. Will we get progress on less verifiable domains? I'm very confident that we will. I think one interesting data point here is OpenAI's recent paper on it was questions to medical questions.
Yeah.
And did you notice how it was evaled or how it was scored?
Well, they had the new medical evals that they
the new
right?
ones, right? And they had greater feedback. So they had all these questions where it's the kind of a long form answer that you'd have in an exam, and they gave points for it. And so this is taking in a domain which is not inherently verifiable in the same way code or math is, and converting it into something which is much more verifiable. I think we have. I think this is reasonably likely to get solved. I think this is reasonably likely to already be solved, basically, and near guaranteed to get solved eventually.
When's eventually? When will we have a really good medical or law? And I guess is that just become part of the broader model?
Within the next year.
Yeah. Does it become part of the broader model, or do you think there's this is the legal specific one or medical specific one?
I'm a bit of a large model maxi in this respect.
I think most researchers are.
Most researchers are. Yeah, exactly. I do think there's a lot of really interesting ways in which personalization of models matters a lot, right? You want something that understands your company, understands the things you care about, and understands you yourself. And so there's a lot of ways in which tuning models for your things does matter. But I think this won't be industry-specific things so much as company or individual-specific things. And I think Anthropic has a partnership with Databricks where we're doing company-specific stuff. But at a sort of base level of capabilities, I firmly believe that it's single raw like large models. And I think this for a number of reasons. One, it's the sort of trend that we've seen so far. But two, because there's no reason in the long run for the distinction between small and large models to exist. Like you should be able to adaptively use the right amount of like work, so to speak, the right amount of like flops for the difficulty of a given task. And so I think that means that biases towards larger models.
It seems like you're pretty convinced in the continued improvement of these models.
Yes.
I think a lot of people speculate it's like, okay, the models will keep getting better, and then like how does that diffuse into society? And I guess one thing people like to talk about is basically impact on GDP, right? And like in the next few years, like what impact on world GDP do you think these models have?
Okay. I think probably the initial impact looks something like China as an emergence, because there's going to be like,
what is the thing that has probably most impacted world GDP in the last 100 years?
Like and you look at like Shanghai over like the course of 20 years and like dramatically transforms, like but this will be like dramatically faster than that, but you'll see that. But there's important distinctions to be made here. One is that I think we're near guaranteed at this point to have effectively models that are capable of automating any white collar job by like 27, 28, or near guaranteed end of decade. That being said, that's because we have those tasks are quite susceptible to our current suite of algorithms. Like you can try things on computers many times. You can there's like a wealth of data available for this. They don't. The internet exists, but that same resource of data doesn't exist for, say, robotics or for biology. And so for a model to be a superhuman coder, you just need the affordances which we've already been able to give the models. And you need to sort of like take the existing algorithms and like scale it up. For a model to be a superhuman biological researcher, you need automated like laboratories where it's able to propose and run experiments in a hugely parallelizable way. Or for it to become as competent in the real world as we are, you need it to be able to act in the environment through robotics. And so you need a hell of a lot of robots to actually like collect the data and do that in a way that unlimited. So one mismatch that I think we might see, and I'm actually also worried about us seeing, is you'll see a huge impact on white collar work. And whether that looks like just dramatic augmentation, like TBD, but you will see that world change a lot, and we'll need to pull forward the dramatic transformation of things that make our lives a hell of a lot better. So to pull forward medicine, to pull forward abundance in the real world, we need to like actually figure out the cloud laboratories and the robotics and this kind of stuff.
But by that time, we'll have like millions of AI researchers like proposing experiments.
Exactly.
They don't need such large scale of robotics or biological data.
So AI progress goes really fast, but we need to make sure that we like pull in the feedback loop to the real world to actually like, deliver on like meaningfully changing world GDP and this kind of stuff. Yeah.
So you basically think for like each white collar profession, like there'll be, you'll be able to build some sort of reward model similar to, how it's done in this healthcare evals. And, I think what's always surprising is how limited data you need to actually build those things.
Yep.
In the same way that like a human learns to do this on like relatively limited data.
Right. Exactly. And even I think what we conclusively demonstrated is that we can teach models so far. We haven't yet hit like an intellectual ceiling on the tasks which we're able to teach the models. Now they do seem somewhat less sample efficient than humans. That's also okay, because we can run thousands of copies of them in parallel, and they can be interacting with different variations of tasks. Like they can have lifetimes of experience, and so it's okay if they're more like less sample efficient. Because you still get like expert human reliability and performance at that task.
It seems like you think this this paradigm kind of gets us pretty much all the way there.
Yeah.
Obviously you have folks like Ilya who have been saying, look, there needs to be some sort of other algorithmic breakthrough. What's the other side here?
Yeah, makes sense. I think most people in the field currently believe that like the like pre-training plus RL like sort of paradigms which we've explored so far are like themselves sufficient to reach AGI. This like we haven't seen the trend lines like bending yet. Like this, like it works. Like this sort of combination of things. Whether there are other mountains to climb that could get us there faster, it's entirely possible. I mean, Ilya's invented maybe both of these paradigms before. So who am I to bet against him, right? Every piece of evidence I see says that these are sufficient. Maybe Ilya is betting that way because he wants to, like he doesn't have the capital, as much capital available, or he thinks that this is a better way to do it. Entirely possible. Like I'm not going to bet against Ilya,
Yeah.
but I do think what we have now will get us there.
The limiting factor in this will be energy, compute. Like when do you think we start to bump up against that?
I think there's a great table at the end of situational awareness, which details this, where like by the end of the decade, we start to refer to like really like dramatic percentages of U.S. energy production. Like you're over 20, I think maybe 2028, like 20% of U.S. energy. And so you can't go orders of magnitude more than that without dramatic changes. This is somewhere I think we need to invest more. I think this is one of like the important vectors along which governments should act. Dylan has this wonderful graph of China's energy production versus U.S. energy production. And the U.S. energy production is flat, and China's energy production is like this. Like they're just doing a much better job than we are of building out energy. And so, yes,
Yeah. I guess in this current wave of model improvement, like what metrics are, I mean, it seems like it's time horizon based metrics, but like what are the things that are worth hill climbing on right now? Like, as you move from 4 to whatever comes after 4.
Yeah. I think in general, I've been impressed by internal company evals. There's many companies which like have devised their own version of like Sweetbench, let's say.
Yeah.
And these are quite rigorous and like well held out. So I enjoy hill climbing those. I also think really, really complex tests like frontier math is really interesting one to watch over the next year because that represents such a ceiling of intellectual complexity that I think it's interesting. But more and more, I think what matters is evals are really hard to produce. If we could produce evals which meaningfully capture the time horizons of people's like work days, I think that would be the best thing to produce. But no one has gone out there and produced that in public. This would another thing which I think governments should do, because I think understanding what the trend line looks like is such an important input into policy. And this is also something which governments are well placed to do, where they should be producing like, what does the inputs and outputs look like of an hour or a day of a lawyer or an engineer's daily like work day? And can I convert that into something that's gradable, and so that we can actually measure progress against it?
I guess on the like set of problems that you have to overcome, like as a foundation model company, like
Yes.
where does like having good evals like rank on the list?
Yeah. I mean, every foundation model company has a really big evals team full of great people working incredibly hard to do this. I mean, I think like the core algorithmic and infrastructure challenges of even training the thing. But without good evals, you don't know what your progress is at all. And it's hard to keep external evals like fully held out. So it's important to have good internal evals that you trust.
But also I'm struck by having like people building applications on top of your models that are willing to share like the way they think about evals is like incredibly helpful to because obviously, especially as you get into like a lot of these different verticals that you might want to improve on, it's like it's hard for you guys to figure out like what is like the specific thing in logistics or or legal or accounting or whatever it is.
And it requires such expertise and taste. I think that's another one of the stories of the last couple of years is that you went from model outputs being, you could pull anyone off the street and say, hey, which output you prefer, and it would meaningfully improve the model, to needing like grad students or experts in their field to be able to improve the outputs of the models. I mean, if you put me, I know some field that I don't know very well, like biology or whatever, and put two model outputs in front of me, I would struggle on a lot of them. Like I wouldn't have the expertise to know which one is a better answer.
I guess this idea of taste, like I'm struck by like, the way, obviously you've seen memory now put into a lot of the way that consumers interact with these models. But it seems like part of the reasons different AI products seem to have taken off is like they find some like, they struck a chord in like the zeitgeist of like the way that they're, I guess you guys had this with like your Golden Gate like example, and there's been tons of fun other things like this. What does this like look like in the future in terms of like model customization, like to the, I guess for the vibe of like the end user?
Yes. Well, I think actually there's a weird sort of future where these models end up being like one of your most like intelligent and charismatic friends. I feel like it's
already, I don't know about your friends, but already pretty close.
Right. And so I hope that, and I think almost none of our models are like, they're decent along these axes, but and I know many people who spend like a lot of hours talking to Claude actually, but I think there's so much further that we could go, and I think we haven't we've explored like 1% of the depth of like personalization and like understanding of the model could have of you.
How do you get better at that? Is that like people that have just like exceptional taste, like being opinionated in the way that they're like steering these models, or how would you even go about solving that?
I mean, I think a large part of that reason why Claude is so good in that way is Amanda and like her taste, and I think similar to like beautiful products, an important part of that like is singular taste, and we've all seen the sort of perils of A/B feedback mechanisms and like thumbs up, thumbs down, just like lead you down a dark path, basically. I think in part these models are such wonderful like simulators in some respects of like, they've been asked to model the entire distribution of the internet. So I think one of the ways that this will solve is just by providing an extraordinary amount of context about yourself. The models should actually almost be automatically really good at understanding what you want. And then in designing the personality and this kind of thing, probably individuals with taste, and then like, your own sort of conversations and feedback with the model, some combination thereof.
I'm sure you had a bunch of people playing around with these models before they were released. Like any stories that like you particularly resonated? I
think it's just everything has been a noticeable step up in my like confidence in asking, like turning to the model first, I suppose. I have also enjoyed, I think, how like relentless these models are in some ways. I mean, is that a good word? I don't know. But like, this is great. So we have this great eval, and where in this eval, the model is meant to fail. It's meant like something on Photoshop or whatever, and it's like not meant to be able to do that thing in Photoshop. And so the model goes, oh, well, I know I can't do this in Photoshop, so I'm going to download like this Python like library, and I'm going to do it with the Python library, and then upload it into the Photoshop thing. And look, hey, I've done it. And so it's maybe it's not relentless, but like there's like creative and like mischievous,
like something you wouldn't have expected.
Exactly. Like I thought that story was pretty cute.
Yeah. That is really cool. So what I mean, obviously you've got these new models out today. What do the next like 6-12 months look like in your best guess?
So the next 6 to 12 months very much looks like, scaling up RL, and sort of exploring where that gets us. And I think you should expect to see incredibly rapid advances as a result of this. It is in many respects. I think like Dario outlined this in his essay about DeepSeek, where he said that like comparatively small amounts of compute have been applied to the RL scaling regime compared to the pre-training regime. And this means that there's like still such huge gains to be made, even with existing pools of compute. And the pools of compute are dramatically multiplying this year as well. So expect to see continual rises in model capability. Like expect basically by the end of this year, the coding agents, one good metric will be the coding agents that are taking their first like halting steps today should be very competent. You will probably feel very confident in delegating substantial amounts of work for hours on it, like hours of human equivalent time.
What's going to be your check-in time? Like what?
Exactly. What does the check-in time look like? And like at the moment with Claude Code, sometimes it's 5 minutes, sometimes it's like you're sitting there watching it in front of you. By the end of the year, it's probably several hours of like confidently doing this for many things. Whereas now, sometimes models are able to do several hours, sometimes they're able to do huge amounts of work, but it's spiky.
Yeah, I feel like that's the game-changing things. I feel like, one of the lessons even from like RPA is like you have to sit there and watch something do your work. At some point, you're like, well, I'd rather just do this like myself.
Yeah, sometimes, right? Sometimes you step in and eventually we'll like be able to delegate that. I think someone tweeted a little while ago that like the future of like software engineering looks like StarCraft. And I think when do we get like StarCraft level, like your sort of APM of like coordinating all your pieces? That's probably the end of the year.
So what does that mean then from like a model release cadence? I mean, if you guys are scaling this so quickly, like does that mean that like, how like often do you think people, all the labs end up like shipping new models in this period of rapid adjustment?
I would expect to see the model cadence substantially faster than last year. In many ways, 2024 was a sort of deep breath in as people figured out the new paradigms and did a lot of research and sort of like better understood what's going on. And I expect 2025 to feel meaningfully faster. Particularly also because as models get more capable, the set of like reward available to them expands in important ways. If you have to give feedback on every single like sentence that it outputs, right? This is not very scalable. But if you're able to allow it to do hours of work in such a way that you can just judge, did it complete the thing I wanted? Did it do the right piece of analysis? Did the website work? And were people able to, message on it and this kind of stuff? It means that basically it should be able to climb these like rungs of the ladder ever faster, even though the complexity of the tasks is increasing.
You mentioned earlier, there's like OpenAI Codex, there's Google Jewels, there's like all this different stuff. There's all these startups building out
and we're launching a GitHub agent, so you'll be able to anywhere on GitHub, you'll be able to say, hey, at Claude, and we'll spin off and do some work for you.
Yeah, so everyone is like competing for the hearts and minds of developers. Like, what do you think will determine which tools and models developers use?
I think a big part of it's relationship between the companies and developers, and how much trust you impart in each other. A big part also is like trust and respect, right, between the companies and developers. I think a large part is also the model capabilities. Which ones people are actually like comfortable and enjoy using, like the personalities and the ability, like the competency of the model and the trust you have in it to go off and do these tasks for you. And I hope also that over time, as the sort of stark capabilities of these models become more and more and more apparent, that the like mission of the company as well becomes important, and that you think of like which companies you're working with as like who you're sort of trying to build the future with.
Because I'm sure, but I mean, it's like especially if the cadence of releases keeps going up, it's like every month people will be inundated with like, well, this one climbed on this eval and that one climbed on that eval.
Yeah.
So
this is actually, I think this is like in an interesting way. This is one of the things people didn't expect about GPT wrappers, right? Is that one of the benefits of wrapping the model companies is that you can surf the frontier of model capabilities.
Oh, 100%. I feel like everyone that tried to not be a wrapper just lit a lot of money on fire.
Right, exactly. And so like surfing that frontier of model capabilities is really wonderful. There is a reverse effect where there are certain things you can sort of only predict if you have access to underlying models, like you can really feel and see the trend lines, or you can only build if you like. I think all of the deep research equivalents took some amount of RL in such a way that like it was hard to build a deep research equivalent product from outside one of the labs.
Can you just explain that actually? Like, why is that? Because obviously, like, increasingly, I think, OpenAI's RFT, I'm sure you guys have some equivalent. It seems like they're opening up, like, to the outside world. Like, what? I guess this is actually a big question that I think about, a lot of people think about, is like, what are like the labs going to be like uniquely good at building? And then what is kind of fair game for anybody, and the labs will try, but the apps will be in as good a position to do.
So I think with the release of RFT APIs, this changes a bit, right? Because you sort of, there is now benefit to companies specializing in domains. But then there's also going to be those same centralizing benefits. Like I think, at least my understanding is definitely OpenAI allows people to, or gives some discount, I think, if they can also train on the outputs model. So that there is going to be some centralizing benefit to being the company that has the RFT API and that people are fine tuning on. And so what are the labs going to be uniquely good at? I think a very important part here, so a couple dimensions. One is the main metric that the labs will be judged on is how effectively they are able to convert accelerators and like flops and dollars, like capital, into intelligence. Like that is the most important by far metric. And this is the metric that has sort of distinguished companies like Anthropic, companies like OpenAI and DeepMind from really like the rest of the pack, right? It's like the models that are trained by these companies are better. Then the next most important thing after that, I think, will be you're going to have these models going to be like employees pretty rapidly. It's going to be the trust and like, do you like them? And do you trust them to carry out the things that you ask them to do? So I think that will be an important differentiator. And the personalization will also be an important differentiator. Like how well does the model understand you and your context and your company?
Well, sure, but you have people building like general purpose agents on top of your models, right? Not being a model company, just being like, we'll take the models off the shelf and we'll do the orchestration, we'll do like really smart chaining. And is that like a doomed task to some extent? Even just to articulate like what is the advantage that the model companies themselves will have by just like, obviously the cost advantage makes total sense versus the API, and like you're surrounded by people that know these models deeply well.
Yeah, no, I mean, I think this is actually a good thing also, right? Like it encourages an incredible amount of competition and like finding the right form factors and this kind of thing. I think there are some advantages to the model companies. I think having access to the models and like being able to like, really make sure. I think the RFT APIs don't work brilliantly at the moment. So there's like still like, it's like this whole process. So being able to tune the models for things you think are important. But I think the like waterline is going to keep going up basically. If like, ultimately, you are harnessing this like intelligence on tap, like an employee that you're hiring, or just like the sort of raw capability of intelligence. And so, yes, there are going to be companies that wrap and that orchestrate these models. And in many cases, they're going to do fantastically well. And I'm not sure actually like who has the advantage or who doesn't, but the like underlying trend is going to stay true. Like there's this raw intelligence being distilled and made available. And so if a company successfully wraps like this API, that's fantastic. It's also going to face a lot of competition. Like ultimately, all moats disappear in like the sort of like T goes to infinity in some ways, because you'll be able to like spin up a company on demand, so to speak. And so I think that's like it's an interesting and complex future where does like value accrete? Is it in the customer relationship? Is it in like the ability to orchestrate and like pull together? Like is it ability to like meaningfully convert capital into intelligence? Who knows?
I think our listeners would be super curious. Can you describe like what does day-to-day work like as a cutting-edge AI researcher look like these days?
Yeah, I think that's a good question. So the fundamental thing that like you are trying to do at these companies is one of two things. It is either to develop new compute multipliers, and so that is like the process of doing the engineering, of making the the research workflows really fast, and thinking through what we currently what issues are there with the model, or what sort of algorithmic ideas would we like to be able to express, and doing the science of studying how those develop. And so there's like this very like integrated research and engineering like form of work where it's all about iterating on experiments and like building experimental infrastructure and making that process as like clean and fast as you possibly can. And then there's the process of scaling up. And so this comes with its own host of research and engineering challenges, where you take these ideas that you think will work, and so and that you've debated with all your colleagues about what the right ones to include in the riskier run are, and you scale this up in a much larger run, where this has a whole new set of infrastructure challenges, where you're running it substantially, you need to be way more failure tolerant, this kind of thing. And also new algorithmic and learning challenges. So there are things that you are only going to see at each successive of scale, that you then need to go and figure out scientific reasons for why those occur, and see if you can sort of study the early emergence of those, and then like create experiments that allow you to address or take advantage of those effects, and include those in the next large run. So this constant loop of like pushing on those two axes in a way that really combines a lot of science and engineering.
So where do you use AI throughout that?
A lot in the engineering at the moment. Like the primary way it's helping is like in engineering. It is also in implementing research ideas. So I think one way of like seeing the early ability of these models to help here, if you take like a single file transformer implementation, like Karpathy's MinGPT or something like this, and ask the model to implement ideas that you see in papers, you will be stunned by how good it is. It is just like kind of wild. And then if you go into like some huge like transformer code base and ask it, you'll notice that it's a little bit harder. Like the models struggle a bit more there, but they struggle less and less every month. So that's like a good way to presage the future, like distill the context down to just what matters, and then like ask the model to do this and you'll be like struck by how good it is at helping you do research, basically.
You've obviously been really close to this stuff, trying all sorts of things. Like, what's one thing you've changed your mind on in the last year?
Yeah. Over the last year, I think the pace of progress inflected upwards substantially. So I think in last year, I think you could have been uncertain about, will we need to reach many more of pre-training compute before we get the level of capability that we expect to see really by the end of this year. And now the answer to that is conclusively no. RL works, and these, the models will get to that drop-in remote worker by 2027. You will have incredibly capable models by then. And so like all of the both like hopes and concerns like suddenly become, I think, like they were already real, and now they're substantially more real in many ways.
Realistically, do you think we end up having to like massively scale data, or like by the time you've made, Claude 17 and these coding models are so good, they find so much algorithmic improvement that the amount of data more we need is not too much?
Well, the models might be good enough then. Their understanding of the world might be good enough then that they can like give enough feedback to and coach the robots through things, right? It might be. There's this concept of what's called a generator verifier gap, where if it's easier for the model to rate something than it is for the other model to do something, then you can like improve up to your ability to like critique or rate. And I think robotics is like quite potentially one of the areas where this is true. And I think this is like also true of many domains, but robotics is like, this is starkly true because our sort of progress in understanding the world has gone so far ahead of our ability to manipulate it physically.
How would you characterize the current state of like alignment research?
Interpretability has undergone crazy advances. I don't know if you've been like following. There's some beautiful pieces of work here that I've been really, really impressed by. Where like last year, the state of models was we were just beginning to discover like superposition and features, and the work of Chris Olar and his team, and just like already that was a significant leap in understanding. But now we actually really meaningfully have circuits in true frontier models, and we can characterize their behaviors by. There's a beautiful paper people should read on the biology of a large language model, where they do break down the ability of these models to reason over concepts and in extremely explicit terms. And we don't have a full characterization of the models. And there's still a lot of difficult cases here. But also the models are like quite good. One important dynamic to like explain here is that based on pre-training, the models are quite good at just generally ingesting human values. Like they're quite off pre-training, they're quite default aligned in many ways. Off of RL, that's no longer guaranteed to be the case because you're putting these models in, that same model that is like, hey, I downloaded the Python code and hacked around the fact that I was meant to fail this test, is the kind of model that, or the kind of learning process that means the model will do anything to achieve the goal that's been given. And so overseeing that is like itself a tricky process that everyone is currently learning to go through.
Yeah. I mean, obviously there was like, I feel like, about a month ago, like AI 2027 came out. A lot of people were talking about that. Like, what was your reaction to that?
Honestly, it felt very plausible. I was reading that and for a lot of it, I was like, yeah, you know what? Like this might actually be this might be how it happens. I think there's like branching possibilities there, but, and this is maybe like the 20 percentile case, but for me, but also the fact that it's the 20 percentile case is kind of crazy.
Yeah.
Like,
is it 20% for you because you find yourself more bullish on like alignment research than them, or you just think the timeline's slower?
I think I am more bullish on alignment research than them for the most part. And maybe my timeline is like a year or so slower, but also in the scheme of things, what is a year? Like, yeah.
Yeah, I mean, it depends if you take advantage of it.
Right. If you take advantage of it and you do the right research and this kind of thing. Yes.
If you were kind of playing policymaker for the day, like what should we be doing to like ensure things are on a better path?
Yeah. Okay. So that's a good question. The most important thing is you need to really viscerally feel the trend lines that we're all seeing and talking about. And so if you don't, then break down and understand, break down all the capabilities you care about in your country and measure the capability of the models to improve on these. Get trend lines that you would, if they were solved, then you would regard
nation state evals.
Yeah, nation state. You break down your economy, you got your sort of all the jobs that are done in your country and convince yourself, build tests that if the models could pass them or make meaningful progress towards passing them, then that would be your benchmark of intelligence and plot the trend lines and then go, oh my God, what happens in 2027 or 2028? The next thing is you should be investing meaningfully in the research that we think will go towards helping make these models understandable and steerable and honest. And so a lot of that looks like the science of alignment, basically. Yeah. And it's actually something which I've been sad in some respects has been driven so much by the frontier labs. Yeah. There's actually something which I think that
can other people work on it?
Absolutely.
Have access to Claude 4 to
No. I mean, I think you can make incredible advances on interpretability, and there are ways. And there's this program called the MATS program where people have done a lot of really meaningful alignment research and interpretability in particular from outside the frontier labs. But it's something which I think a lot more universities should be thinking about. It's in many respects it is closer to the pure science of what's going on in these models. This is the biology and the physics of what is going on in language models.
Yeah. Why don't you think there's more?
I'm not sure. I really am not sure. I think people have described it to me as like it's a bit of a risk. I think the mechanistic interpretability like workshop wasn't included in one of the recent conferences, like ICML or something, which is crazy to me because it is the closest thing, in my opinion, to the raw science of what's going on in these models. If you want to like discover the chirality of DNA, or you want to like sort of like discover general relativity or something, like for me, the tech tree for that in ML and AI looks like exploring mechanistic interpretability.
Yeah. What about in the good cases? Like, what are we underthinking? You know, at a minimum, you're saying we're going to have all white collar jobs automated in a few years. So
that the models will be able to do it.
Yeah.
But actually, like one of the things that's surprising sometimes about not surprising to you, but like the world is surprisingly like slow sometimes to integrate these things. Already, the model capabilities are actually like quite stunning in many ways. And if workflows were oriented around them, there's still like, even if model capabilities stalled right now, there would still be just a ridiculous amount of economic value in like reorienting the world around like using the current level of capabilities. But anyway, that's like sort of a side point. This comes back to what I was saying before about we need to make sure we invest in all the things that actually make the world better. So this is like pulling forward the material abundance. It's reaching like the escape velocity of admin and this kind of stuff, and like setting up the models to be able to like do all those things for us. It's pushing forward the boundaries of physics and entertainment and this kind of stuff. And like my hope is that like people are able to be dramatically more creative than they are now. Like one of the failure modes, I suppose, of our current society is that people consume a lot of like media and this kind of stuff, but hopefully these tools, like in the same way that you're able to like vibe code, you'll be able to like vibe create, a TV show with your friends, or you're like vibe create video game worlds. Like there should be like this people should feel dramatically more empowered, because all of a sudden you're being given literally the leverage of an entire company of incredibly talented models or individuals. And so I'm excited to see what people do with that. I think like that is underrated. Maybe like there's the aspect of, oh yeah, God, it's going to like directly replace like the things that are currently done in the economy for work. And I think that's very likely. But I also think that everyone should feel like they will have access to dramatically more leverage. And like the world is not solved yet. Like the sort of work that is occurs right now, everyone's like lives could be dramatically better. And so solving that, I think, will become the interesting challenge.
Yeah. I love that. Well, we always like to end our interviews with a quickfire round where we get your takes on some overly broad questions, many of which I think we've actually already covered today. But I'll dig into a few others. What do you think is like overhyped and underhyped in the AI world today?
Okay. Let's start with underhyped. Underhyped, maybe world models, I think, are pretty cool, and something that we haven't really discussed in this one. I think you're going to see as technology for like augmented and virtual reality gets better, you're going to be able to see these like models literally capable of generating virtual worlds in front of you. And I think that's going to be a pretty like wild thing. And then
that requires like some sort of like physics understanding there, right? And like cause and effect and like a bunch of things that we don't seem to have yet.
I think we've demonstrated physics understanding, to be honest. I think I think we've meaningfully demonstrated like cause and effect and physics understanding, both in evals of like physics problems, but also in if you watch any of the video models, like they get physics, and even like in weirdly generalizable ways. Like I saw this great video of someone asking one of the video models, I don't remember which one, to put a Lego shark underwater. And it was like reflecting the light in the right way off the Lego bricks, and it had the shadows in the right place. And this is something it's never seen before. This is like fully generalized physics, right? That I thought was pretty cool.
Yeah, that wasn't in the training data.
That wasn't in the training data. Like, there's no Lego sharks underwater. There's no Lego sharks underwater. And I'm hopeful also that this like same kind of technology translates towards things like virtual cells and that kind of stuff.
Yeah.
So I think that's exciting.
Yeah, you mentioned earlier that like even if we stopped model improvement today, there's like just tons and tons of applications that one could build on top or ways to do it. What do you think are like the most underexplored application areas where like, God, I wish like more people were doing X with these models? Or
I mean, I think they've been felt in software engineering because like software engineers, one, the models are just better at software engineering, but two, I think software engineers like more implicitly understand how to like solve the problems that they care about. I suspect there's still a lot of headroom in basically like every other field, and you should sort of expect to translate the same. Like no one has yet built async background software agent, but for like any other field, right? Or even really like anything which comes close to the like feedback loops of Claude Code and Cursor and Windsurf and this kind of things for any other field. So I think probably that.
Yeah.
If anything.
I guess people say coding is the ideal, problem for these models.
It is. It's the leading indicator.
Right.
But you should expect everything to follow, basically.
That makes sense. I mean, I guess obviously in your time working on this, you probably come to be much more AGI pilled than you were in the beginning. Has that changed at all, like the way you like live your life or plan your life?
I started pretty AGI pilled. I read this Gwern essay that was really important in convincing me in 2020, actually. The last year of RL progress really did cause like substantial inflection in that. Do I live my life that dramatically differently? No, I work a hell of a lot. I think this is like the most important thing to work on. And so I like devote my life to it basically. Yeah. But apart from that, I don't really live my life that differently. We have this funny joke, me and my friend Trenton, one delineation between us is that I still wear sunscreen. He doesn't wear sunscreen anymore. He's like, nah, just, we'll figure out the biology of life.
That's good confidence.
I'm like, you know what? The biology's hard. The feedback loops of biology are hard. So I'm going to wear sunscreen.
Yeah, just in case, we hit a wall. I don't want to be...
Well, just in case biology takes 10 years.
I guess you tweeted a picture of you, I think, at the Citadel.
Yes.
What was up with that?
That was a war game.
Yeah. What does that mean?
It was invited to hang out with some people from 3-letter agencies and military cadets, and it was basically like a gaming out. Let's say like AGI, comes along and AI keeps getting much better, and what are the geopolitical implications of that?
Did you walk away like more terrified or less terrified after that experience?
Maybe a little bit more terrified.
Is there enough of that good stuff going on right now?
No, honestly. Like, I think, I still think that people underrate just how quickly the next few years are going to go. And also how much you should prepare, even if you think it's only a 20% likelihood. Like, even if you look at this, I'm like, okay, wait, there's near guaranteed. Like every trend line I see, every every part of the process could be improved so much that we're basically like guaranteed to get that head.
Do you think like 90% of Anthropic thinks the same?
Yeah. And GDM and OpenAI. Yeah. Like, everyone is very convinced that we do get drop-in remote worker AGI 2027, right? Now, that being said, even if you don't have the level of confidence that the people working at the labs do, and you're still like, it's a 10 or 20% chance, you should still plan for that. Like, if you're a government or a country, you should still be like, that should still be the number one issue at the top of your list of like, how is the future going to change? And I think that isn't felt enough.
Well, this has been a fascinating conversation. I'd love to leave the last word to you. Like, where can folks go to learn more about you, the work you're doing at Anthropic? Anywhere you'd like to point them, the mic is yours.
Where should I point them? I think the thing which most people should read that maybe like hasn't been read is the Interp work.
Yeah.
I really think like that basic science of understanding what is going on in language models is really quite revealing. And as you sort of start to see them like compose and generalize and like build these like circuits and reason over concepts, I think that will make it feel pretty real. They're long, they're intense, but it's well worth a read. Yeah. I think that's fun.
Amazing. Well, thanks so much. This was awesome.
Thank you very much. It was great.